Welcome to Study Loop.
So the information we are given is all on the screen right now. For part A, we simply need to describe the process. B to A is an isobaric expansion where the pressure is constant. Let's call this VC, let's call this VD. Okay. And A to D is an isovolumetric compression. Isovolumetric reduction in pressure. So in process B to A, the volume increases and the pressure is constant, which means work is positive. Whereas A to D, because the volume is constant, work is zero. Now D to C, the pressure is constant and the volume decreases, so work is negative. And from C to B, it's another isovolumetric increase in pressure where the work is zero because the volume remains constant. For part B, we want to find out the total work done by the gas during the cycle. So obviously in A to D and B to C, the work is zero. So the total work done is simply work done during B to A and work done during D to C. Now, we use the same trick as we used in the last two problems, number 38 and 39. So work done during BA is QBA minus EBA using the first law of thermodynamics. And during DC, it is QDC minus EDC. Now that we have this, we know that work done during the process CDA is 38 joules. But notice that the work done during DA must be zero, which means this is simply work done during CD. Which means work done during the process DC is negative of minus of that, so that's minus 38 joules. Now that we have this, notice that work done during BA is P delta V. That is pressure at B times VA minus VB. And from the graph, it's obvious that we know that PB is 2.2 PD, and we know that VA is the same as VD, and VB is the same as VC. So using that, we can write VA minus VB as VD minus VC. If you notice, this is P delta V for the process D to C. So that's work done during the process DC. So using this, we can see that work done during process BA is 84 joules. Therefore, the total work done is work done during BA plus work done during DC. So that's 84 minus 38, which is 46 joules. For part B, we want to find the total change in internal energy. I'm sorry, for part C. And because total internal energy, the internal energy depends only on the state of the system. For a circular loop, the system comes back to its original position, which means the change in internal energy is zero. For part B, we want to find out the total heat during the process. Now this gets a little tricky here, but it's pretty straightforward. The total heat is simply the total change in internal energy plus the total work done. The total internal energy change is zero, and we saw that the total work done is 46 joules. So, which means the total heat supplied to the system is 46 joules. Now for part E, we need to find the efficiency. Efficiency is a little trickier. Efficiency is work done by the system divided by the heat supplied to the system, that is the heat that was expended in doing this whole cycle, times 100. So in our case, heat is supplied to the system only during DC and CB. So Q supply, the heat supply to the system is simply Q DC plus, heat is supplied during BC and BA. So QBC plus, CB and BA. So that's QCB plus QBA. Heat is supplied to the system, and now we know that QCB is ECB plus WCB, and QBA is EBA plus WBA. Now, because BC, in the process BC, the work done is 0, WCB is 0, so we have WBA plus ECB plus EBA is ECA. Now, if you remember what we found that WBA was 84 joules. So we have 84 joules plus we need to find ECA. Now for ECA, we use this information. ECA is QCA minus WCA. We are given QCA and WCA directly. So that's minus 85 minus 55, which is minus 30 joules. I'm sorry. This is ECA and QCA and QWCA. Notice that this is QAC and this is WAC. So what we instead found was EAC. EAC is equal to QAC minus WAC, which we found to be minus 30 joules, which means ECA is minus EAC, which is 30 joules. Therefore, ECA is 30 joules, giving us 114 joules. We already know that the work done by the system is WDC. The work done by the system was 46 joules. Therefore, efficiency is 46 joules divided by 114 joules into 100, which turns out to be 40% up to two significant digits.